Okay, so 5.2, we're going to look at exponential functions. This will be day 1. In this video, you're going to see a quick review on the rules of exponents from Algebra 1 and one exponent that's a review from Algebra 2. You will also see the beginning of how to graph what are called exponential functions. Okay, so it's going to be important that you understand these review problems as we go over them, and I can see that you've been looking at them, but no big deal. I want to make sure that you understand, look, you're going to need to know these rules of exponents as we keep going, so I'm going to kind of breeze right through them because some of them should be very, very easy. If you look at numbers 5 and number 7, maybe those are going to be the two difficult ones for you. But 1, 2, 3, 4, those should be really easy. Number 6 should be really easy as well. So take a look. Number 1, x to the 5th times x squared. Think when you have the same base and you're multiplying, you keep the base and you add the exponents. Number 2, now you're dividing, you keep your base and you subtract your exponents. Number 3, what I can do, because there is no plus or minus sign there, I'm allowed to distribute that exponent of a 4. I'm allowed to distribute that to everything inside of the parentheses. So x squared to the 4th, remember when you distribute you are multiplying, so x to the 8th, y to the 12th. Number 4, very, very simple. Anything to the 0 power is 1. Number 5, this one might be a little tricky, so I'm going to take this one a little bit slower. Remember, you're not allowed to have negative exponents. You have to make those negative exponents positive. So think, it's negative in the numerator. What I do is I move it to the denominator where it becomes positive. So understand that when you have negative exponents, you always have to make them positive by moving them to the opposite location. Think like, what if I gave you 2 to the negative 2nd power? Well, I could rewrite that as 1 over 2 squared to get 1/4 as my answer. So it's going to be important that you understand negative exponents, so please be careful with that. I could also ask you to work in reverse. What if I gave you 1/6 and I asked you to write that using a negative exponent? Come on, it's going to be important that you understand how to do this. So 1/6 is the same thing as 6 to the negative 1st power. Okay, going to be important that you are able to interchange between the two of them. So please be careful about that. 6, simple, distribute to the numerator and to the denominator. Number 7, careful, these are called rational exponents. Remember, a rational number is a number that can be written as a fraction. So think it's a rational exponent because it's a fraction. How do I deal with this? I'm just going to kind of show you something that you're just going to have to study. Oops, let me go back there. Notice that what's going to happen is that your denominator is always going to be your root. Your numerator is always going to be your exponent. Okay, so understand, denominator will always be the root, numerator will always be the exponent. So I think that says the cubed root of 8. Well, the cubed root of 8 is 2. 2 squared is 4. Just to kind of double check, if you want one to practice right now, what if I gave you like 4 to the 1/2 power? How could you rewrite that? Well, think 2 is your root, so it would be square root of 4, and then the exponent is 1. Square root of 4 is 2. 2 to the 1st power is obviously 2. Okay, so think about that. Again, make sure that you are able to work in reverse. What if I gave you the 4th root of 5 squared and I asked you to write that as a rational exponent? Well, what you would do is keep the base, the 5, numerator is always the exponent, denominator is always the root. Okay, so important that you are able to go back and forth between those as well. Only just trying to help you out because I know what's coming. Alright, so now that we've reviewed exponents, let's talk about how to graph exponential functions. Notice we call them exponential functions because our exponent is always going to be a variable. Okay, exponent is always going to be a variable with exponential functions. So what I want you to do is I want to kind of fill out this XY chart. So think 2 to the negative third power. If I did this first one, I'll show you it. 2 to the negative third is the same thing as 1 over 2 to the third, which gives me 1/8. Okay, so I know in here 1/8. Keep going, 2 to the negative second, 2 to the negative first, 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth, and 2 to the fifth. Okay, so understanding that you have those numbers there, hopefully you were able to get those pretty easily. I have those in there, so here you go. There they are. Okay, so from here I'm going to plot those points. I'll show you when I plot them. Take a look. There is my, when I plot them, notice I plotted as many as I possibly could. Please be careful. Notice right here, I did not cross the x-axis because what's going to happen is you are going to have this horizontal line here where what's going to happen, we talked about limit notation. As x approaches infinity or x approaches negative infinity, right? Do you remember that limit notation? So I'm telling you, as x is approaching negative infinity, right? As x is going to the left, what I'm telling you is that the y value is going to approach 0, meaning it's going to get as close as it possibly can get to it, but it's never actually going to touch it. Okay, so understand it's going to get as close as it possibly can, but it's never going to touch it. That has a special name. Well, obviously it's the line y equals 0. What we call that line, we call it a horizontal asymptote. It's the line that my graph gets as close as it possibly can get to it, but it's never actually going to touch it. Okay, so that is called a horizontal asymptote. And I think this is going to be a good place for us to stop today. Rules of exponents, please make sure you understand them. Graphing exponential functions, it's going to be important because here comes some more parent functions, right? You already have 6 of them. Here comes some more parent functions, so please ask any questions that you have today. We'll get some practice, and good job.